Hey everyone, and welcome to this explainer. Today, we're taking a look at a profound, almost invisible shift happening all around us. If you follow the news at all, it's so easy to get caught up in AI doomerism, this idea that artificial intelligence is just a looming threat to our entire way of life. But today, we're completely changing the lens. We're going to explore the incredible, democratizing power of the open source revolution. I want you to picture this new era not as some centralized, faceless corporate monolith, but actually as a glowing, global isometric network. It's a massive, decentralized web of shared knowledge that is literally empowering everyone, from local clinics to researchers in developing nations.
To really grasp the true scale of this revolution, just consider the number 200 million. That represents the exact amount of protein structures that are now freely available to the entire world through the AlphaFold Database. 200 million. That is practically every single protein known to science, completely mapped out and entirely open for anyone to explore. It's a genuinely staggering figure, and it proves we're leaving the days of locked-away research in the rearview mirror and stepping into an era of totally unprecedented global collaboration.
Okay, let's dive into this. We'll start by looking at the end of gatekeeping, then move into biology's open-source triumph. After that, we'll tackle the famous 2 Sigma education problem, explore how we're democratizing daily productivity, and finally finish up with a look at our new decentralized global network.
Section 1. The end of gatekeeping. Moving from siloed data to global intelligence.
For generations, things like elite education, cutting-edge biological data, and high-level productivity tools were strictly locked behind massive wealth. If you were a researcher in a developing nation, or maybe a startup with zero capital, you were simply priced out of the frontier. No way around it. The old gatekept era relied heavily on siloed data and months, honestly sometimes years, of grueling manual research. This effectively localized all wealth and progress to just a few elite institutions. But today's open source era, it's completely different. It's defined by universally accessible, global collaboration where compute takes minutes, not months. We've shifted from a very slow, isolated past into a dynamic, hyper-connected present. And the wild part? The primary catalyst for this shift is actually happening inside our own biology.
That brings us to Section 2, Biology's Open Source Revolution, the AlphaFold Triumph. AI is fundamentally changing biology from what was essentially an observational science into a predictive, global collaboration. Right now, the AlphaFold database is actively supporting over 500,000 researchers worldwide. And what's truly incredible here is the sheer educational impact of these open access resources. By democratizing training in computational biology, this massive network of data is flowing freely across the globe, which is actively empowering researchers in developing nations to finally bridge the scientific divide. They no longer need a multi-million-dollar crystallography lab to do cutting-edge science. They can rapidly develop drugs for local, global infectious diseases right from their laptops. Biological breakthroughs are now being driven by global collaboration, absolutely not by gatekept data. And this brilliantly illustrates just how fast this change is happening. According to the Sovereign Tech audit, before AlphaFold, we had over 5,000 unsolved human proteins. Post-AlphaFold, we're down to just 29. The dark proteome, those mysterious, totally unmapped parts of our biology, shrank from 26% down to just 10%. And maybe most importantly, cancer target chemical screening times have dropped by a massive 70%. We are literally shrinking research timelines from years to mere minutes.
Section 3. Solving the 2 Sigma problem. Scaling elite education.
Now, this democratization of data isn't just curing diseases, it's completely transforming how we learn. To understand why this is such a big deal, we have to look back to 1984. When an educational psychologist named Benjamin Bloom defined what he called the 2 Sigma problem. Bloom found that students who received one-on-one tutoring performed 2 full standard deviations better than their peers in a standard classroom setting. That jump pushed them all the way into the 98th percentile. But Bloom had a massive dilemma. Providing a personal, elite tutor for every single child on Earth was totally economically impossible. Well, until right now.
Recent educational meta-analyses, along with data from the Sovereign Tech audit, show a massive historic shift. While traditional classrooms generally keep students at the baseline 50th percentile, generative AI tutors are catapulting learning outcomes all the way up to the 84th percentile. We are finally bridging this massive educational gap at a scale we've never seen before. AI tutors are providing the kind of adaptive, personalized learning that used to be strictly reserved for the ultra-wealthy, basically making elite education an open-source utility for everyone.
So the crucial point is that AI isn't replacing teachers. Not at all. Instead, we're looking at a true hybrid human-AI tutoring model. Think of the AI as a cognitive forklift, offloading all the heavy lifting of continuous adaptive skill mastery. Meanwhile, the human teacher steps in to provide the empathy, the accountability, and that vital motivational connection that a machine just can't offer. Working together, they are nearly doubling learning gains, especially for lower-performing students.
Section 4. Democratizing daily productivity. The agentic workforce.
We're also moving from how we learn directly into how we work. We have officially entered the agentic era, where AI acts less like a basic chatbot and way more like a highly capable coworker operating right alongside you. Based on data from Forrester and Digital Applied, the drop in cost per task is honestly staggering. For example, a routine code review that would normally cost $48 in fully loaded human engineering time, that now costs an AI agent just 72 cents. A Tier 1 customer service ticket drops from $4.18 to just 46 cents. High-level productivity and operational efficiency are just no longer exclusive to mega corporations. This level of cost reduction makes elite workflows totally accessible to a solo entrepreneur or a brand new startup.
And the ultimate result of all that efficiency? 6.4 hours. That is the median number of hours saved every single week by knowledge workers who are using production AI agents. By handing over routine, standardized tasks to AI, workers are literally getting their time back. That's over a full day every month reclaimed to focus on strategy, creativity, and deeper problem solving.
Now, addressing the broader economic impact, we can look to the perspective of NVIDIA CEO Jensen Huang. He notes that the massive infrastructure build-out required for AI is actually generating immense job growth, bringing back manufacturing and skilled trades at a very large scale. From this viewpoint, young people who are adept at using these open-source tools will be highly employable. The underlying data supports a landscape where technology is acting as an engine for new industry creation and human augmentation, rather than just simple job destruction.
Section 5. A decentralized global network. The infrastructure of the future.
Let's move to and see how this builds. Because for this revolution to truly belong to everyone, it requires a very specific foundation. We absolutely must guarantee that this open-source intelligence remains accessible, private, and entirely out of the control of any single centralized power. Looking across the timeline, we started back in 2018 with massive, centralized cloud data centers. Then, to handle the crazy energy needs, we looked at off-grid subsea compute like Project Natick in 2020. But jumping to 2024 and 2026, we're seeing the rise of decentralized peer-to-peer networks like Petals and local quantized edge frameworks like BitDistiller. The compute itself is literally moving from locked corporate servers directly into your local off-grid devices.
So why does this matter? Well, edge infrastructure means you don't need to send your private data to some massive server farm. Local quantization allows incredibly smart models to run efficiently on everyday consumer hardware with very minimal memory. It means the ultimate power of this global network isn't owned by a single corporation, and it's not gated by an expensive subscription fee. It is fully decentralized, highly private, and distributed directly into the hands of the global public.
From unlocking the deepest secrets of our biology, to giving every child an elite tutor, to literally taking back our time at work, the gatekeepers are gone. We have successfully transitioned from isolated data silos to a vibrant, decentralized global network. The tools to solve some of our greatest challenges are now resting right in the palm of your hands. So my final question to you is, in a world where intelligence is an open-source utility, what will you build next? Thanks so much for joining me on this explainer, and I seriously can't wait to see what you all create.